In this brief video, we will look at actually solving the first example in our lecture materials. You see here the example shown again, same as it was listed in the lectures. I also already have installed the solver add-on for Excel. If you don't have that installed, you won't be able to follow along with this video, so make sure that you have that. Okay, let's go through this quickly. We have our decision variables shown here in yellow, how many of each type of shelf or bookcase we're going to make. We have here the profit that we receive off of each individual type, and the green cell is the total profit. Now that is a live calculation. If you click on that, you'll notice there's a formula in there. So if I change the number of shelves I'm making, it automatically updates the profit. It's very important. If you don't have a live spreadsheet, this won't work. Then we have our constraints. We have how much time it takes in the trimming operation for each type of bookshelf, how much on the shaper, and how much assembly time. Again, in red, these are live calculations using the sum product command in order to determine the total amount of trimming time, shaping time, and assembly time needed based on how many we're currently manufacturing. Then we have our capacities listed here. This is simply so that I know the capacities. These less than signs here are just for me to remember that the values in red must remain below the values in blue. Okay, now let's use Solver to determine the solution. We're going to go to Tools, Solver, and a new window will come up. Now I already have this pre-populated, but let me talk about it. First of all, our objective function is the cell E8. You can click here, click on the E8 cell and hit return and it will automatically put it in, or you could type E8. So our objective is profit and we want to maximize the profit. We're going to do that by changing our decision variables. And those are B5 through D5. That's our values in yellow here. Okay, so B5 through D5. Oops, I changed the wrong thing. Let me change that back. Our objective is the green cell. Our variables, our decision variables, are the yellow cells. Okay. Now, our constraint, we have three constraints, but we can enter it as one constraint because we can use ranges. So we're going to say G11 through G13 must be greater than or equal to E11 through E13. Or you could switch that around and say E11 through E13 must be less than or equal to G11 through G13, however you want to enter it. So you will need to add that constraint. I'm also going to make sure I have clicked this little box. This is very important. This assumes that you can't make negative things. So we're assuming the variables are non-negative. So in other words, I can't make negative bookshelves. That's important because if you don't say so, Excel won't know it. Finally, I'm going to select the solver type. This is a linear problem, so I'm going to use the simplex method, which is what's always best for linear problems. And I'm ready to go. So let's hit the solve. It does some calculations. It says I did find a solution. All the constraints and the optimality conditions are satisfied. Do you want to keep it? And I'm going to say yes. So it's saying optimally we should make 150 standard bookcases, 300 narrow bookcases, and no wide bookcases. Even though the wide bookcases have a large profit margin, they take too much time on the trimmer compared to the other things, and it uses up our trimming time too quickly. You'll notice down here we're fully utilizing our time on the trimmer, we're fully utilizing our time on the shaper, but we're greatly underutilizing assembly time. That tells me that although this is a solution, that tells me the real solution to this problem, what I've really learned is that I need to rethink my company and reallocate some of the personnel in the assembly area to other activities because I have way too much assembly time available for what I need.